Recording? Recording? I believe so. Yep. All right. So my name is Christian Lacotte, and I'm going to be going over what my project was this year for 452. Before I get into the actual diagrams and stuff like that, I'm just going to talk about what essentially I was trying to do from the get-go. So basically, I was trying to get a PlayStation 3 controller and hook it up to the computer and make it essentially act as a mouse. The analog sticks were supposed to be able to move the mouse cursor, and the buttons were actually supposed to act as like a mouse event. You know, when you actually like a right click, left click, or it could be used like, let's say, you're on Firefox to go back and stuff like that. So now I'm just going to dive into the actual state diagram. So it's going to start off in the ready state, and it's just going to wait there until it actually has some type of input. So input being like a button has been pressed. So once a button has been pressed, it's going to go to the validate input state, and from here it's just going to check if the input was from actually the controller or not. And if it's not, it's going to go back to the ready and it's going to sit there and wait for another input. But if it is, it's just gonna go to the action queue. And the action queue is where it was is the queue that's storing all the actions that are being completed, and it's a first in, first out type of ordeal. So it's just a basic queue, nothing too serious. So after it gets into the action queue, it's going to go into a branch, and depending on what was pressed, so if it was, there was a button or it was an analog movement, it's going to decide which state it's going to go to. So if it was a button press, it's going to go to the button event handler, and this is going to act as two separate threads that are actually going to run concurrently. So that's how that works there. And then after it gets let's say for instance it was a button. After the button gets pressed, it's going to go to the action update and it's going to remove it from the queue. Now this is the original design, but I actually updated it because instead I used signals instead of a queue because I thought it was going to be better since I'm using a controller. So it's basically the same graph. I just took out the action queue. So I'm going to move over to the sequence diagram. So the sequence diagram, so this is this top half over here. So it's going to start off, so like a key press. The controller is going to, once a key is pressed, it's going to go to the device driver. And the device driver is going to be what's used to handle. Actually, it's going to be used to device driver is used to handle the actual inputs, and it's going to be directing what is actually going to happen. So device driver is what it's going to do, is going to add the button to the queue, to the actions, and the queue is located in the actions object. And then it's going to tell it it's a button press, and then it's going to enter into a thread. So this right here is a thread for both the button handler and the joystick handler. So the button pressed or a joystick moved, and then it's going to perform the action concurrently, and then they're going to remove from the queue. And this is what would happen if it was an invalid key. It would just go back to the control and just wait there until a new key is pressed. So that's that part. Yeah, I'm gonna move on to. Oh yeah, okay. So I just have a bunch of actions drawn up for what each button would do essentially. So like if in the thread, let's say like the A button was pressed or X, it's gonna the button action is going to send it to the button action. The button action will actually handle the action there, but then the action will get removed from the action after it's set. And the same thing essentially for the joystick actions as well. And I kind of just have that for most of these down here. Just different types of different buttons just to have them. And this is just my class hierarchy basically. So the controller is going to associate itself with the device driver. And the device driver is gonna, this is what we went over in these sequence diagrams, where it's gonna validate the input, log the key presses and button press and stuff like that. Now these two classes here are what are going to act as the actual threads in the actual implementation of it. And now I'm no longer really using a queue anymore. I'm using signals instead. So this is everything else is pretty much the same except for the queue is now gone. Um, yeah, so that's that part for the class. But actually, I'll go a little further into it. Like the button handler, each button will have a different type of action, and you can map this to many different things. The same thing over here with the joystick handler. So that's that for the basic design, and guess I'm going to move over to the actual implementation. Is it not sharing? Which screen is it sharing? I'm not sure if it's showing the Debian screen or not. All right, so I'm going to go ahead and run this. So I have a connect button, and it's basically I'm just going to connect this here to the controller. And this is actually what's going to start running the threads. Now I couldn't actually get the mouse movements to actually work how I wanted them to, but it's still okay. You know, I got a decent amount done, I believe. But so I'm just gonna show off like so here is just gonna show you which buttons you pressed, and I have every button mapped on here. And when you start moving the trigger, you'll see in the L2 and R2, you'll see that if I hold down R2, you can see like the pressure I have on the trigger actually. And same thing with L2, and you can do these at the same time. That's what I like about that. It's pretty cool. And also, when you start moving the analog sticks, like in a certain direction, you can see how they actually interact. So, like, this is actually what's supposed to essentially act as the what was actually supposed to move the cursor, but that involved a bunch of kernel objects and stuff like that, and that was just way out of reach. But got the basic implementation down, so pretty happy where I got with it. Actually took a while, but I can actually show you some of the code here. So, go to the main. So basically, these are the threads I used here to create the actual. Like this is the button handler essentially, and this is the joystick handler. And these are the sockets I use, or signals. My bad, not sockets. These are the signals I use. And Qt it's a different implementation than like POSIX signals, so that's what was nice. It was actually kind of hard setting it up at first because it's a little bit of a learning curve, but once you get it down, it's perfect. But so yeah, this is just like the setting the pictures and everything from when you get the button, stuff like that. The left analog stick, the right analog stick function. This is like the trigger bar. That's actually just showing like the triggers, button threads. So this is what was the button handler. So this is actually how I read in from the controller. Actually took a while. I mean, this might not seem like a lot, but it actually took a while to come up with. And this is actually how you run the actual thread, and this is where I'm actually getting all the inputs from. So this is the actual device that we're reading it from, and it opens here. So this is the PlayStation 3 controller device, and you actually get to open it right here, actually. But once that is open, if it doesn't open, it'll give you an error and saying, nope, you cannot connect. But it usually connects unless it's unplugged. Um, This is like the while loop here for reading the events. So this is just for the buttons. So this is gonna take a joystick event button type, and I have my mutual exclusion box here, just because the event numbers are both used in both threads. So that's the only reason why I'm using that there. But this is actually how you use the signals in Qt. You use the emit, and this is what took a while to actually set up because it's just a lot different than what I was used to. So that's maybe that. Here's a joystick thread. It's almost the same. Actually, not really. This was actually more challenging because I actually had to get the accesses, and the axes is just that was not fun. As you can see, like down below, like you can see when I'm moving it, you can see all the accesses. The axes, my bad. You just see them all moving. But this is the run function for the actual thread for the joysticks. And it's going to open the device just like the other one. And these are both running concurrently, by the way. And so here we have the access where it gets its actual state. And then it's going to check which state it is. This is part of the struct, actually. And I have a mutual exclusion again here because of the event numbers. And then I have 3 different emits. So this emit was, this is just for this part. This part over here. That's the same with the right analog stick and left analog stick. But yeah, that's basically what I have for today. And thank you for joining me.